Hello everyone, this is Team Shinigamis and today we are going to demonstrate something about rolling. But first, what will be your answer if I ask you what is the shortest path to travel between any two given points? The answer is obviously a straight line. But is that the efficient way? Let us take an example. Imagine you are in a beach and you see a person is drowning in the sea. You have to save him. Now consider that your speed while swimming is faster than while running on the sand of the beach. Then what would be the fastest way in order to save that person? If you choose to travel by a straight line, then, well, unfortunately, you might be late in saving his life. What if I tell you that there is an efficient way than by traveling in straight line? In this case, if you travel less in sand and more by swimming, that will be the fastest way. We have to take into consideration other things like the angle while entering the sea, which depends on how fast you can move on both beach and in the sea. When the ratio of the sine of these two angles is equal to the ratio of the speeds on both the places, the resultant path is the quickest or the efficient route. This is known as the Snell's law, and we all know light always obeys it. This can be seen in the refraction phenomenon of light. You know that light always follows the route that is the fastest for it to travel. This solves a problem known as the Brachistochrone problem, and it was solved by Bernoulli. Now consider this. With only gravity to move, what is the fastest way to roll from a point A to some other point below B, not directly below? Would it be a straight line? That is the shortest path, of course. And now consider falling vertically a lot right away and moving with top speed during most of the journey, which makes up for the fact that it has to travel a longer distance than the straight line afterwards. Is it the efficient path? Finding the path of least time is called as the Brachistochrone problem. In 1697, Bernoulli solved this problem using light, which always shows the fastest possible route. We all know that light travels faster in air than other optically denser mediums like water and glass. All he had to do was to add more and more thinner layers of the mediums in the path of light, in which the speed of light was faster and faster, and there he got the Brachistochrone curve, the path of least time. If you have a curve like this and if you roll down an object, it would beat anything rolling down in any other paths every time. This path can also be described in other ways like cycloid. The cycloid is the path traced by a point on the circumference of a circle in which the circle is rolling along a straight line. To demonstrate this, we have a model with two paths, a straight line path and the Brachistochrone curve path. And we have two rollers. Now if we roll down these rollers in these two different curves, in these two different paths, if you observe carefully, the roller rolling on the Brachistochrone curve path reached the end first, and of course it is our winner. Even if we do this for any number of times, The roller rolling on the straight line path will never ever beat the roller on the Brachistochrone curve path, and this is the most efficient path. The Brachistochrone curve path also has another property. If you leave two rollers on two Brachistochrone curve paths where both the paths have same properties, the rollers will reach the end together. In fact, even if the two rollers start at different points, they'll reach the end point together. Isn't it astonishing? Thank you for listening to us.